Jai Hind all. This is a lecture series on data communication network. I am Gagandeep Singh. This is the first lecture on the data communication networks, and we are discussing a primer on the data communication networks. This lecture includes all topics that are required for the whole syllabus, the glimpses of all the topics that is required to be discussed in the syllabus. So this is not only for the introduction of the data communication networks, but also it is required for the whole journey for the syllabus. So in this lecture, we will discuss the introduction of the data communication networks, the goals of the internet network, and then the applications of the internet network, then network structure and architecture in the data networks, the internet protocols and the standards, the difference between the two, the layered task, the two main layer tasks, OSI model, reference model, and TCP model, and then the TCP addressing, and last we will discuss the line coding. So if we see, all these topics are included in AKTU's Unit 1. So we are basically discussing the AKTU's Unit 1. So for whole discussion, I'm referring to the first book, which is the Frozen Data Communication Network, published by McGraw-Hill Education. There is another Tannenbaum book which is famous for this one, data communication networks. Then there are other books that we can refer, is the William Stillings and Ajit Pal for the local author references. But here in this lecture, mainly I am referring this book, Data Communication Network, 4th edition. There is the latest editions are also available for this book. So first of all, what is a data network? Data network is a communication of the data between the two devices. Here in the data communication network, we require first one is sender, that is generating a message. So second is a message. Third one is a receiver that is required, which is receiving the message. So there is a sender, there is a receiver, there is a message. Then fourth one, a medium is required for to communicate between the two devices. So if we see, these are the 4 requirements of the communication. But for the effective and the actual communication, we need a fifth component, which is the protocols. A protocol is a set of rules that we will discuss again later in the lecture. That it is a set of rules that are required for the effective communication. For example, if the two senders, if a sender is transmitting a information which cannot be translated by the receiver. For example, if there is a communication between the two between sender and the receivers is not as per these rules, they cannot communicate with each other due to the not proper division of the channels or the every rule that is set in the protocol. So these are the 5 components that are required for the communication between the two devices. In the data communication networks, these the sender and the receiver, or the devices that are in between the medium, these are called nodes. Nodes, nodes. And the medium that is in between, that is joining the receiver and the transmitter, is known as a link. So a data communication network is a network between the two devices, minimum 2 devices, 2 or more devices, connected with a link. And for a communication, there is a set of rules that are with these rules we are transmitting a message from sender to the receiver. So with this one, if we want to create a network, we need to have fulfill 3 criteria. First one is the performance. Performance means that the network must be dependent upon the number of the users. So the performance, as the number of the users will increase, the performance of the network will be assumed to be better because of the large occupation of the users, large consumer size. Again, the type of the communication will also decide the communication type, the performance of the network, then the network hardware, and the type of the communication between the hardware and the software is the performance key elements. Then there is also the transit time, that is that measures the performance of the network, that is the time taken from a message to travel from sender to the receiver. Then there is a response time by which we can the receiver can respond to that network's call. Then throughput and delay, which is basically the data rate and the delay in the network. These are the basic three performing parameters to measure the performance. Then another parameter to measure the criteria is the reliability. Reliability means how accurately our data is being transferred to the destination. This is the reliability. That means the accuracy of the delivery is the main reliability, as well as that reliability means that the message should be transferred to the destination. That means there should not be failure in the delivery of the message. So it also measures the frequency of the failure, the time it takes for a link to recover from that failure. Then third one is the network security. Network security is important because if more than two users are there that are transmitting in a network, then network security became a bigger issue. As we will incorporate more number of users to increase the performance in terms of cost, then in term of revenue, then we will have to secure our information. So these three are the network criteria that we should take into consideration while designing a network. Now, when we are designing a network, we have designed a network, we are fulfilling a network. To understand that network is working properly or not, we need to have these four characteristics that are to be checked. First one is the delivery. That whether the system is delivering the data to the correct destination, or devices correct destination means the device to which the data is intended to be transmitted. Second is the accuracy. Accuracy means that the delivery of the data is accurate and there is no alteration in the in between the medium from the source to the destination, or there is the actual message is being transmitted to the receiver. So this is the accuracy. Then is the timeliness. That means timeliness means there should be a minimum delay. That means it should not be that the delay is so much higher that the data became useless. So we need a timeliness between the source to the destination. There should be minimum delay, especially for the real time applications where we want a really very small delay. Then is jitter, which is again some part of timeliness, but jitter is the accuracy of the delivery of the data packets or the bits. That means if there is a uneven delay, if I am transmitting 1, 2, 3, if let's suppose I am transmitting 1, 2, 3, this can be data, or this can be packet number, or this can be information or a sequence number, anything. If I am transmitting 1, 2, 3, if there is a uneven delay between these different packets, so there may be, first of all, at the destination 1 reaches, then reaches 3, then reaches 2, due to the uneven delay. So this packet that I have receiving, or the information that I am receiving is wrong. So this uneven delay is known as a jitter. So we want to have least uneven delay in the communication. So these are the fundamental characteristics of a network that are needed to be checked while we are considering that. Now, when I am transmitting a data from source to the destination, there are three ways in which I can communicate or I can send the message. The first one is the simplex, in which there is one node which is only transmitted. It cannot receive the signal. And there is another node which is only receiving the information, but it is not transmitting the signal. For example, the example given here is from PC to the monitor, where monitor is actually fetching a video only. There is another type of information is, for example, the TV broadcast, where the TV is receiving the signal and displaying the information only. So DVS, which is DTH or DVS, is the main system which is working on the simplest way, whereas data is only in the one direction. Then second is the half duplex, where two stations are there and both can communicate, but one will transmit at a one time. The second station will transmit at another time slot. So at the same time, both will be not transmitting. So at time one, the whole channel is being used by station 1 for the communication between 1 to 2. And for the time slot 2, the station 2 will transmit for the sender 1. So there will be whole utilization of the channel in that duration. Here we need to have set up some communication protocol, so that when sender 1 is transmitting, sender 2 do not transmit the signal. Third one is a full duplex, where the channel is being used by the both at the same time. Both, here I am taking the simplest method, that there are only two stations over there. So both stations can transmit the signal at the same time. Now here there are a number of problems. For example, we need to classify the channel. It can be in any ways, for example, by the TDM or by the FDM or CDMA. Second, there should be avoidance of collision, for which we require again protocols. Best suitable example of the half duplex is the walkie-talkie, where one user calls and then transmit the signal, and the other user transmit the signal only when the first station has stopped the communication. The third one, full duplex, as the example, best suitable example is the mobile phone, where both the users can talk or can transmit the signal at the same time. Simultaneously, they can converse. Now, after creating a network, we need to check these goals are being fulfilled or not. Broadly classifying the goals of a network. First one is the resource and the load sharing. This means that we are a single resource is being shared by a number of users. For example, for one room, we simply connect one printer. Now this printer is a resource, and we can share it with a number of other devices. So for that one, we need to have a internet network. Then reduce cost. Obviously, when we are using a single device instead of a printer for each device, we are reducing the cost. Similarly, we can see it in a software sharing, software resource sharing, where we are sharing the resources, or we are installing a server on one device, and we are sharing it through a number of devices. Then highly reliability. Highly reliability means that if we want to take a print again, for the printer example, if we want to take a print again, if one PC shutdowns or one PC do not work, then we can take a command through the other other device. So our task will be still fulfilling, so our reliability is high. Also, if we want to have a broader picture of the internet network, we can see that we can send mails and we can set up a communication through these networks. Other goals that are included are distribution of the processing functions. For example, a single function is being done, and we can divide that function into a number of steps, and these steps can be distributed over the network devices. Then centralized management. The management of the whole whole network can be done centrally. Then allocation of the network resources, for example, the printer example. Then compatibility of the dissimilar equipments and softwares, where we can make a one software installed in a one network, and that can be used with the older version on the other device. Then the network performance. Network performance means the scalability, the saving money, access to the remote information, and person-to-person communications. So all these are the basic, goals of the network. To create a network, we generally use one of these. We set up one of these goals to create a network. Now, when we have connected two or more devices, there are generally different type of connections. So when there are two devices that have a dedicated link between the device 1 and device 2, that type of network is known as a point-to-point link or point-to-point connection. When there are a number of other stations that are communicating with the one source, which is one source is the transmitter, and a number of sources, 1, 2, 3, number of sources are there, then these are the multi-point communication. Multi-point communication, there can be a number of other ways in which it can be communicated. But there is one link that is being shared by a number of other users. So there is a multi-point, there is a point to multi-point, multi-point to point. There are a number of ways which we can connect these multi-point connections. Now, when we have a multi-point connection, there are different ways in which we physically connect the devices. The way in which we physically connect the devices, this is known as a topology. There are 4 basic topology. One is the mesh topology, second is the star topology, third one is the bus topology, fourth one is the ring topology. Now, if we have, let's suppose, 4 devices, one device, if it is connected with the other 3 devices, this is known as the star devices. So the circles are the nodes and lines are the links. So this is a kind of star topology where one node is a central to the other 3 nodes. In the mesh topology, if we have 4 nodes that are to be connected, each node is connected to the other 3 nodes. So this node will be connected to the all 3 nodes. This node will be connected to the all 3 nodes, as well as this node will be connected to the all 3 nodes, and last one node will be also connected to the all 3 nodes. So this kind of network is the mesh network. Here in the bus topology, if I have 4 nodes that are to be connected, they are connected through a single bus line, and each device will be connected to the bus line with a drop line as well as a tie. So there will be, all these devices will be connected to the bus line as well as to this bus line they are connected to the drop line. So this main line is known as the bus. So there will be end terminals from which this bus starts and bus terminates. These are the end devices or end terminals that are connected. There will be a tab which is connecting these devices to or to the bus, which is also known as the connector. So broadly we can say that the connectors are connecting the devices to the bus. Ring topology is similar to the bus topology, but there is a one major difference, that there is no end devices or end terminals. All devices are connected with each other to form a ring. So these are the basically four type of the topologies: mesh topology, star topology, bus topology, and the ring topology. If we compare these topologies, there are different criteria on which we can compare. First of all, if we see the links, because this one is the major cost of a setup of the network. As the link will be more, there will be more cost of the setup of the physical setup of the devices network. So mainly bus needs one backbone and n number of devices. Then there will be n number of drop lines or n number of connectors to connect the devices with the bus. Then in a ring, again we will have a one backbone and n number of the drop lines. The only difference is that there will be no end terminal in the ring topology. For star, if there is a n number of devices, there will be n number of links that are required to connect with the central point. Then for the mesh network, there will be n minus 1 by 2 number of n into n minus 1 by 2 number of links that are required. The number of ports required is the another cost of the network establishment. So for this one, each device require only one port for the bus topology. For the ring topology, again we require only one port, because only one connector will be required from a bus to the main bus to the device. So only one port is required that connects the device to the number. Again, for the star, each device requires only one connector, port connector. Mainly, more number of ports are required for the central connector. For the mesh topology, for each device will require n minus 1 number of ports. So there will be large cost on the ports as well as on the number of links or the cables for the mesh topology. Then the cable required depends upon the network size, but obviously for the same number of devices, this bus require only the bus line. This also require bus line only. The star requires connection between each node to the central point, so it requires a little bit more. But for this mesh network, obviously we require a much more network cable for the links. Network performance is for the bus due to the collision domain, single collision domain, a bus where the packets can be collided is only a bus. So for this one, bus line is has a smaller number of performance. Here it can be dependent upon the collision between the synchronization between the different devices. It can be small or a large. Here, due to the single network failure point for the star, this was a kind of star network. If we have a single network failure point, this can be has a smaller performance depending upon this single central point. Then mesh network, where we need again a smaller number of smaller performance because of the large number of ports as well as the large number of the connections between the one device to the other devices. Traffic, if we see that this has a less traffic, but the traffic is mainly communicated through the bus network. This has a highest traffic ring topology, because the traffic that is being transmitted is circulating or is being revolving only in the ring. Then star topology, which has a medium traffic, because of the only central point will communicate for the all type of the communication. Mesh topology has a dedicated point-to-point link. So mesh topology has least traffic in this in the whole network. Data flow efficiency, if we see, this has a every has a bus only, so there will be more data flow efficiency. Central point control is there, so the star point has also a more efficiency. The mesh topology has a dedicated link, so there will be also again a more efficiency here. But here the efficiency we cannot determine high or less. It can be dependent upon the protocols, the number of devices, as well as the number of the packets that are being transmitted. So for the same number of devices, the ring topology will have a average type of data flow efficiency. The cost, mainly here, bus has the bus cost only. Here the data cost is higher. Here the cost is mainly dependent upon the central node, and the mesh topology has more cost due to the higher number of links and the higher number of ports in the network. Then failure, if we say, if there is any failure in the bus, it will be easy because there is only bus line where the failure can be happening. Here it will be difficult to solve because of the structure of the ring structure of the network. So if one device fails, it will be difficult to find out that what type of network failure is there. Then for this one, if for the star network, if there is a central node fails, the whole network goes down. Otherwise, if node X fails, then central point can easily say that this link X is not working. So we can easily solve this troubleshoot the network. The mesh topology, it will be very easy because there is a dedicated link between the source to the destination. So we can easily define where the failure has happened. So this will create easy to detect the failure of the network. Now, when we are connected the devices in any topologies, we can create a bigger networks with these topologies. Dependent upon the size of the network and the topologies used, we can classify in different ways. Basic classification of the wired network is LANs, where the size of the network is generally with the private networks that is confined to a building, a campus, a office, and an office. These are the with the confinement only to the few kilometers. So generally these LANs, local area networks, that are known as the LAN, local area network, these LANs have a data rate of 100 Mbps to the 1 Gbps nowadays. Then there are wide area networks, which is spread over larger area, generally from a country, a continent, or between the two different countries to completely occupy the whole world. So these are the WANs. Generally, there are switched WANs which are connected from end to end by internet networking devices. There are point-to-point networks also there. In between these two, this LAN and wide area network, which is WAN, there is another network which is metropolitan area network, which is generally connection between the two states or a larger cities or towns to connect these one only. For example, telephone lines or cable TVs. These are known as the metropolitan area network, MAN. Besides there can be a combination of the other newer networks. For example, personal area network, which is where very few devices are there, and there is that is confined to only a single room. Then a body area network, which is confined only to the human body. So there are a number of other devices, other networks of the classifications of the networks also. There can be a wired LAN, for example, wireless LAN that we are using in nowadays in our phone. So that is known as a WLAN, WLAN that can be classified in this one. Now, when these networks are again different categories of networks are again connected, they form internetwork. So when two or more networks are connected, they became internetwork or internet. Short form of internetwork is internet. So internet is the combination of two or more networks. So now when there are a number of devices from the different categories of the network are joined, they must be connected such a way that there should be some protocols or standards being followed. So to communication to be take place between the two devices, some set of rules must be theirs. The set of rules that governs the data communication are known as the protocols. A protocol has generally three key elements to define. One is the syntax. Syntax is a structure or the format of the data in which the data is being presented, in which the data must be given from source to the destination. Then semantic, the meaning of the data, each data bit, but the meaning of each data bit is the semantics. The pattern or the different pattern, for example, we have discussed the jitter. The jitter may change the pattern of the bits. So the semantics will define that what is the pattern of the data that is required for the action that is to be taken. Then timing. The timing, generally there are two ways in which we can say that the timing of the protocol is set. First is that when data is sent, and second is the how fast or how slowly we can send the data. For example, we have discussed that for a LAN we have 100 Mbps to 1 Gbps, that is set by the data rules or a protocol. There is some standards also which are required. Standards are generally different from protocols. Standards are the guidelines that are provided by the manufacturers, vendors, government agencies, and other service providers. For example, internet service provider that are required to ensure that a kind of connectivity that are required for the marketplace or internet standards are essentials that are maintained. Generally, these standards are created by two ways. One is by facts or de facto or de jure. These or by law. So these ways two standards can be formed. So if we review all the things that we have discussed, first one is that we need two devices, two nodes, and that are connected with the link to set up a data communication. There are 5 components required for essentially for the to set up a communication. One is sender, receiver, message, medium, and protocols. There are 4 fundamental characteristics of a network. One is the accuracy, delivery, timeliness, and jitter. There are 3 types of ways which we can with which the data can flow: one way at a time, and 2 ways: simplex, half duplex, and the full duplex. Then we have also discussed that there are 3 network criteria which I call it as a network criteria triangle: performance, reliability, and security. Then there are different goals of the network which are mainly created for the network so that we can establish a network. The main goal is resource sharing, so that network cost can be shared, the load can be reduced, the user experience can be better, and the cost can be lower down. Then there are two types of connection. One is a point to point and multi-point. From point to point and multi-point, we have different type of the topologies. There are four basic topologies. One is a mesh, star, bus, and the ring topology. When we join one or more topologies, there is a hybrid topology. One hybrid topology is the tree topology, which is derived from the star topology. Then we have classified the network based on this topology. When we have joined the different topologies, there are different networks which are LAN, MAN, MAN, and WAN. When we connect all these, then there is an internet that has been created. Now, to study these internet, we need to have a layered structure. A layered structure is the division of the task of the different devices so that we can study the network. So this to study the layers, we classify the whole process into different tasks, smaller tasks, where we can divide these tasks in the different layers of in the internet, or different nodes of the internet. So this is known as the distributed process. For example, if we do a task and we divide it into different parts, for example, washing clothes, if we give it to the different persons, that one person will segregate, another will wash it, other will reason it, and other will dry it. So this is the distributed process where the different persons will be involving, and each person is doing its own task. So this is known as a distribution process. To make a distribution process happen, we divide the whole network into the different layers. There are two ways in which famous ways with which we classify the whole network into layers. One is OSI layer and other the TCP layer. Both the OSI layer has 7 layers, and each layer has a fixed task to be performed. The physical layer is the main task is to transmit the bits over the medium. The main task of the data link layer is to organize into frame and transmit from hope to hope or node to node delivery. Network is from source to destination delivery. Transport layer is main task is for process to process delivery. Session layer is to establish, manage, terminate sessions. Then process is to encrypt, compress, translate the data. Application layer has main task to allow the network resources. For example, user can access the internet through the Mozilla Fire. That is the application layer, which is allowing the user to share the network resources. Deeply we will discuss in the main topic, or the extra lecture for the TCP, the IP OSI layers. The TCP layer is again derived from the OSI layer, but there are different layers which are from there. There are application layer, presentation layer, session layer, transport layer, network layer, data link layer, and the physical layers which are being presented in the OSI layer. The TCP IP layer has divided into 4 layers, but we can also classify it into 5 layers. The 4 layers of the TCP is application layer, then transport layer. This is known as the IP layer or internet layer. Then 4th layer is the host to network layer or data link layer and the physical layer. So these are the 4 layers in which the TCP IP has divided the whole network. Now TCP IP are working for host to destination delivery by using the different addressing schemes. There are 4 basic addressing schemes which are required for the delivery of the message from the one source to the destination. First address, the different address are physical address, logical address, port address, and the specific address. First one, physical address is generally given at the physical layer, underlying physical layer, which is a MAC layer, MAC address of the network. Generally, MAC layer do not change for a device, but if we change the port, then we need to change the MAC layer. But for a device, there will be a single MAC layer. Then there is a logical addressing, which is IP addressing, IPv4, IPv6, MIPv6, PIPv6. All these addressing schemes are in the networking layer or the logical addressing. When this logical address is required for the source to the destination delivery, whereas MAC address is required for the hoop to hoop or node to the next node delivery. But we need to deliver the packet from the source process to the destination process. So for source to the destination packet delivery, we require the transport layer port address. Port address is the address of the process that is going on in the device. The both port address and the logical address, when both are combined, this is known as the socket address. Socket address. This socket address is the IP address plus port address. So for a process to deliver the packet from the source process to the destination process, we need a socket address. Generally, we are dealing with the specific address when we are working without having the IP addresses or other addresses. These are known as the specific addresses. For example, google.com or akgec.ac.in. So this address it comes under the specific address. So this is all that is required for the first unit or for the introduction of the introduction of the syllabus. We also need TCP IP in the deep inside, for which we will discuss in the subsequent lecture. We also discuss the OSI model in the deep and their working of the each layer, the task of the each layer in the subsequent lectures. Thank you.